dad,
Yeah.
so I watched every single movie.
Like even the old one,
Yeah, from
like
the first one to
Moonraker.
what's now.
Moonraker was like my dad's favorite.
Oh, Moonraker's the best. I like Moonraker because Josh turns blue.
I don't know if I can say best. Like it's really hard because it depends on which Bond was like. Like I think each Bond had their own best Bond movie.
In the game.
Okay. All right, ladies and gents. I need your attention. If you are not ready to turn in your homework yet, I will put this on the chalkboard so it's up at extensions as well. I am going to start class in like 30 seconds. So you are going to try to turn it in now, get them out, staple them together, turn them in, make sure your name's on them. Otherwise, take care of it at extensions. If I'm being honest, I probably won't check them until tomorrow. So if you turn it in early tomorrow, you'll probably be okay. But I will write over here Math 7 and then what assignments are getting turned in.
I have a question.
Yes.
Where do we put our stuff?
You got top bin. Always top bin, regardless of when you come here. You guys are the top bin.
Oh my god.
And then we should all look like Adrian and Joey and Skylar. No, Isaac's paper. Oh, that is your paper. Okay, and Isaac.
So this is 3.2.3 is on 3.2.2.
It's 3.1.1.
Oh, I have all my homework because I keep up with my homework.
Oh my gosh, Eva.
What's the whole
All right, ladies and gents. Thank you very much. You can do me a favor, pass these out.
Do you want me to put this?
Top bin, always top bin. Ava. Isaac. Kevin. Ethan. Then everybody needs one of these half sheets that Aiden is passing out. Then everyone needs one of these half sheets. I kept your other stuff because you turned in the chapter 3 stuff already. So you're good on the 311 and 322, I think. Okay, I know we're here at a weird time. I know you're not used to doing math in the afternoon. I know you probably have more energy than you normally do, but we need to focus because I only have like about a half an hour. Right, because of Jam and AO and all the transition time, we wasted about 5 minutes probably at this point. So please make sure you have the half sheet hundredths grids. I have hole punched it, but as you'll notice, it only fits 2 of them, so you can put it in your binder if you want. There is no specific front or back, but we will only use the front or back today, like one side. The rest of it's for you to be able to use with homework. Isaac, you're going to sit there, you got to try to lower. Because that one will lower. Well, then I'll take it. I was about to say, either I'll take it or somebody can. So, is anybody, while people make sure they have a header on their paper, hey guys, you're going to sit back there and not talk, because I've been talking for like a minute solid and you're still carrying on. Do we have a header on our paper, Kevin? I don't know why you're talking to Nathan if you don't have a header on your paper. So what? I guess I'm not sitting down today. Or I'll sit on my stone table. Alright, so just like, and if you want to read along with me, your group should have a book or 2 out and open. Just like decade has that prefix dec, that's That's another name for 10 years, right? And dec really, no matter what it's on, means 10. Decimal, the first place is your 10th place, and then every place after that is a 10th of the place before. So decimals operate all in base 10, which is why the grids that you have here are 10 by 10, right? It's a hundredths grid representing those first kind of 2 decimal places. So our entire number system is based on tens, unless you talk about America-specific values. Now, time, that's just kind of annoying. It doesn't have a good base. But like our America-specific values, inches, yards, all that stuff, Aiden, you got to try to drop down so you're not blocking people's view. That is all base, whatever nonsense we decided. Inches, yards, miles, all that, like that's all nonsensical bases. If we go to the metric system, do you hear that, people? That for some reason, 7th graders think it's appropriate to just be like singing while a teacher's teaching. I can't believe it. I really can't. Some of this year is like super amazing, and some of this year is really confusing. But if you would rather be singing right now, I don't even have a door blocking your way out. Peace. See you later. But if you want to learn some math, that's what we're here for. I have legitimately 30 minutes left to get all this lesson. Which we can do it. I have full confidence that we can, but not if I have to keep stopping and like. And the other thing is like, if you're sitting there singing or humming or making noises while I'm trying to talk, you're obviously not listening to me. Just do me a favor and flip me off and walk out so we can take it to Mr. Shirley. Because you really have no interest in listening to me, just make it obvious. Or if you would like to teach class, I would love for you to teach class. If you think, I already know this, I could teach this just as well as, great, here's the pen. Like, take it, come up, do it. Otherwise, you've got stuff to learn.
You even said people could come, like, show you, like, the homework.
Oh, yeah. If you want to, the students have taught my class before. It's awesome. Now, it only works if they can handle it. But I had one student who was so good at it, he came back because he went to Linworth, and he came back as part of his, not his walkabout, but like when you're younger than walkabout, if you guys know about Linworth, yeah, interim. And he taught for a month. He taught one of my classes, like to practice what it would be like to be a teacher. It was sweet. He thinks he's going to be a high school teacher.
I have one question about Linworth. Does Linworth and Dearborn, like, share classes?
No matter what your home high school would be, if you need to go back to the home high school to take that class, they will bus you back.
Okay.
So, like, if there's not a class at Linworth that you need, they'll get you back there. So, today our study is going to be all about money, because it is a nice base 10, or you could say base 100 system, because everything goes down to cents. Excuse me, which there are 100 cents in a dollar, obviously. So, questions to keep in mind. How are decimals like fractions? What does place value have to do with our answer? And does the answer actually make sense? That's always a good question to be thinking about. If I tell you that you are going to get a discount on an item and your answer comes out being more than what you started with, that doesn't make sense, right? If you're getting a discount, you should end up paying less. So Howard is fortunately going to get a discount here. So he's at the mall, and there's a sale, things are cheap prices, and there's a sale going on. So yes, I know the price I'm about to give you. You're like, well, there's no way that would actually be a price. Okay, I get it. This is one of those things where just to make the math problem easier for you, we're going to let ourselves believe that shoelaces could only cost 40 cents, which even shoelaces would probably be more than that. But Howard goes to the sporting goods store, and he sees the sign on the front that says, all sporting goods, 1/10 off. Now, if it's 1/10 off, can anyone tell me what I'm going to end up paying? Not like money, but like fraction-wise. Ooh, hand just went down. Kevin?
9/10 of what it is.
Yeah, if I take 1/10 off, I'm going to pay 9/10. So he looks at some rollerblade laces, right, because he ripped them because he's too strong, and they're 40 cents. So he grabs a hundredths grid, and he shades 4 of those columns to be his 40 cents. So I need everyone on whatever one of those you choose, you could just do top, left, or whatever, point to this and tell yourself it is $1. Which is really, and I have not used this symbol in a very long time, 100 cents. right? $1 is 100 cents. So we shade 40 cents. And go ahead and shade. Take a moment. Make sure you shade in 40 of those blocks. Do it vertically, please. Don't try to get creative and like do it differently. You're just shading in 4 columns because columns go up and down, right? Columns hold up the building. True confession, I had a very hard time learning columns versus rows. I don't know why. But then I came here, and Mrs. Pettigrew teaches you guys about the different types of columns. And then I got it. I was like, oh, yeah, columns hold up buildings. They go up and down.
Just pillars.
She was a science teacher back then.
You went to school?
No, when I first got a job here.
Oh.
Sorry. Ava, you know I'm not from here. I'm from Coshocton, like rural farm town. We've got cows and cornfields.
That's Ohio.
Yes, most of it. Most of it.
I'm from Miami.
So then he needs to calculate, well, what is my price going to be after my discount? So then, and you could change colors if you want or shade a different direction. See how my squigglies all kind of go one direction? He needs to figure out what is 1/10. Now hold on, give me your eyes for a second. He needs 1/10 of what he's supposed to pay. So give me your eyes for a second. I'm going to help you avoid the traps here. If I shade in 1/10 of my grid like this, does that help me? No, but that doesn't interact with the part I'm setting up right now. If I shade in 1/10 of my grid like this, does that help me figure out what's 1/10 of 40? No, actually. Because that would actually be 1/4 of 40. So what we need to do is shade in 1/10 like this, because we need to go the opposite direction from what we started. And what we're looking for, right, Natalie? What we're looking for is the double shaded. So here, after you shade the other direction, you need to figure out what is double shaded. Like how many of those boxes. And what we get told down here, 0.4, really this should have a 0 on it. 40 cents. We would not write money as just $0.4. That's not really appropriate.
Wait, so this is like the box things when we're trying to figure out.
Like when we did, yeah. So when we cut the boxes apart and we did like what's 1/2 of 1/8, or those, this is the same thing. You got to go perpendicular, which means change direction. If I went up and down first, my next shading has to go left and right. If I go left and right first, my next shading has to go up and down. So how many were double shaded? 4. So he's going to save 4 cents and end up paying everything that only got shaded once. So what does he pay for the shoelaces? 36 cents.
Now you can spend that 40.
Yeah.
Now you can spend those 4 cents on gummy bear.
I know, right? Maybe.
One gummy bear.
Honest. There's still a store in Coshocton that sells candy for a penny. Like, if you've ever heard the expression, like, penny candy, like, it's like Tootsie Rolls and stuff like that. But yeah, you can still find places that... So we used to go down there with, like, $3, and we would count out, like, 300 of these pieces of candy. That's probably also why I became an overweight child. All right, questions on what we just did, because you're going to have to do it on your own then. Questions on what we just did.
We have to put this on our
Dude, if you can't, like, sit low, then you can't sit in it. So that's on your hundreds grid. That's, like, your notes right now. So, the other way, what should go on your graph paper now? Hey, hi, Ava. What should go on your graph paper now is if we didn't have a grid to help us here, we could then say what is 10% of 40, and we could either do 0.40 or just 40. Like if we want to do 40 cents, we could do that, but I'm going to leave it in dollar form because dollar form is what we're used to. Please write that on your paper. Then we're going to change this. Well, what does 10% mean? Brennan?
1/10 or maybe 1/10 or 10 over 100.
Yeah, it's 1/10 or 10 over 100. If I set it up like this, I can then like get rid of the stacked zeros. So 10% percent is just 1/10.
Or it could be 0.10.
Or we could make it decimals. And then 40 cents, well, I could actually just, I don't need that last zero. I can just write it as 4 tenths. And what we get when we multiply this, please write down these fractions, I'm not asking a lot. We go straight through top, straight through bottom. And we get 4 out of 100, which is 4 cents. Right, so if we're talking money, 4 out of 100 is 4 cents.
What was the point of doing that?
If you didn't have a grid, if you didn't want to visually draw it out, how could we show the math another way?
Oh, so you multiply 10 times half.
We go straight through top, straight through bottom with fractions. When multiplying fractions, it's easy. Straight through top, straight through bottom. Adding is much more difficult. Now here we could add because we have common denominators, but that's not what we're doing. Question?
You broke the table.
All right. So now, Howard, guys, I don't know where this is coming from, but I need your focus up here. Okay. Now, Howard found some new running shoes. My brother's actually a marathon runner, and people really do care about this stuff. That say that they are 70% of the weight of the previous shoes. Like same model, but like this year as opposed to last year's version. So will they weigh more or less? So check out the setup here. They weigh 70% as much as his old ones. So what percent would be the same as the old ones? 100%, right? 100% of what you used to have gets you the same thing. So if I have 70% of what I used to have, do I have more or less? Less. Those shoes weighed 0.8 kilograms. The new ones are 70% of that. Your job is using the hundredths grid, find 70% of 8 tenths. So the first thing you want to do is set up your 8 tenths, right? Shade this first. Then shade in going the other direction, 70%. Whatever's double shaded is the new weight, right? The new is 70%. So whatever gets double shaded. So when I do this, for my 8 tenths, and we're probably over here now. Don't like that line.
This is confusing.
So what I have in blue up here my blue is the old shoe weight, right? 0.8 kilograms, because the rest of the world uses grams. Then going the other direction, because I should have said this sooner, so I'm sorry, but when you first shade, don't shade very dark, because you want your next shading to be able to darken up compared to your first one. So now going the other direction, I'm going to shade 7 of my rows. I can either do the 7 top or 7 bottom. And now I'm going to do those up and down. Just like the mastery that we just took that you guys will be getting back tomorrow. So I want to get everything updated and all that. We're just looking, it was like a couple weeks ago. It seems like a long time ago. How wide was my blue set here? 8, right? It was 8 out of the 10. How tall was my red set here? What's 8 times 7?
56.
56, but here, the new is 50, it's not 56 kilograms, right? That doesn't make sense.
No.
These are 56 boxes out of how many boxes do I have in the whole grid?
100.
100. So it's 56 out of 100, or 0.56 kilograms for the new weight of the shoes. We shade it in, and you might want to write this like above this or something. What we represented here was 70% of 8/10. You guys, 70% is really 7/10. It's 70 hundredths. We can erase those extra zeros, and it's really 7/10.
Are we gonna review how you do it now? Like how we did like the 0.40, like 1/10 to 4/10, 400.
So, if we want the alternative method, which you don't have to write this, let's say I grab this and I want to just do the math. I'm going to bring it back over here. I'm going to capture this and then I'm going to bring it back over. That would be fraction equation. And guys, this is good just to get your practice written down. This is 7/10 times 8/10 is all we're doing. 70% is 7/10. 0.8, when said properly, is 8/10. Goes straight across the top, straight across the bottom. Fraction times fraction. What's 7 times 8? 56. 10 times 10? 100. So we get 56 hundredths. Now the decimal equation, I don't like this as much. Like, it's just not as nice in my brain. Here's the issue. So we got 0.7 times 0.8, right? 7/10 times 8/10. So we can do 7 times 8, but this is where people make their mistake, is how many decimal places should be in the answer. Anyone know how to figure out how many decimal places should be in the answer? Ava?
Well, okay, so isn't there 2 on the right side of the decimal point and then 1 on the left side?
So that's 1 decimal spot, right? So what Ava's saying, and this is another decimal spot. So in the setup, how many decimal places do I have? 2. My answer will have 2 decimal places. 0.56. I used 2 decimal places.
What about the 2 on the other
On the left, those don't count as decimal places. Those are actually whole value places. And since they're both zeros, they don't really matter.
If you reach 100, you just put a 1.
Good afternoon, George Minister. Please come to the office. George Minister, please come to the office.
Questions on this?
So wouldn't it be 56 cents you paid?
It's, sorry, what?
Would it be 70 cents you paid or 56 cents?
This is not pay. This is how much they weigh. So this is actually kilograms. If you want to put a label on there, put a kg on it. Not KGB, but just kg. Kg for kilograms. What does kilo stand for? Eva? Oh, it's 1,000. Yep. So, kilograms means 1,000 grams. Now, a gram is very light. Like a gram, like you can ask Mr. Kabila, he's got weight sets. A gram is very light. But a kilogram kind of starts to have some heft. So this is less than a kilogram that these shoes weigh. I guarantee my shoes I'm wearing right now weigh more than a kilogram. They're not running shoes, they're dress shoes, they have thick soles. Guarantee they weigh over 1 kilogram. But these are running shoes. They weigh just over half a kilogram. Yeah. People what? If they're runners, yeah, it's just less to pick up.
I'll make a fortune and selling invisible shoes.
I have a couple pairs of shoes that actually are like toe shoes, and I learned like camping and hiking, but they weigh like nothing. So it's as if you're walking barefoot. Like it really feels like you don't have a shoe on. Yeah, I'm one of those weird guys that wears the toe shoes. Now, my wife has said that I'm not allowed to wear my current pair to school because you guys will die when you smell how bad they smell. So thank my wife for the fact that your nose has not been subjected to that, but I'm probably going to try to buy a new pair. I can ever get ahead of this basement project that we're in the middle of. Yeah, like when I wear jeans or
That's
something.
classy.
Ew, miss. Oh my god.
You're gonna be one of those girls that gets weirded out by the
My
fact
mom
that
had
I
that.
wear shoes.
That's
Toe
classy.
shoes
No.
and jeans.
Yeah, I'm sorry. I'm a fashion guru.
You know what they look like.
Yes,
Yes.
like
The only thing I
my
Okay, we're gonna move on. Understand that there are like hundreds of different pairs, and you'll scoff at this, and I get it, but I love telling you guys funny stories. One of my friends got married in toe shoes because chill. They were black leather made of it was like Australian leather, like really really nice. But they were toe shoes.
I do that.
Now
And my jeans.
that friend, chill. Stop with the fashion judgment because I really don't care what you guys think about what I wear. Sorry, I
I'll
just
grab
don't.
it now.
Thanks. I didn't wear the tie because the temperature keeps going back and forth. I don't know what I was gonna say, but we need to do math. Oh, he now works down. Have you ever been to Hocking Hills, giant park down there? He works in the park. So that's like what type of guy he is. He's a very outdoorsy sort of guy. I hate multiplication. Now, fraction multiplication's easier, but I was taught how to multiply based on the stacked multiplication. Line up your decimals, drop it down. Every time you move a place, you add an extra zero. For some reason, I never understood what those zeros were doing. It all didn't make any sense. Now, if I had been taught the way that we are trying to change how we teach math, I think I would actually like multiplication because this makes it easier. So everyone on your paper, please write out 2.3 times 1.4. Now, even if you're very, very smart, I doubt that you can quickly calculate 23 times 14. And it'd be even harder if you try to keep the decimals in there and do 2.3 and 1.4. Right? That gets very tough, right, Nathan? Like, you probably don't want to do that multiplication, right? And we probably have old methods from elementary before we switched over to CPM, where we would stack it and multiply and all the nonsense, but we're not doing that.
It's 110. Sorry, it makes me mad when people do that. And you know, when they offer
It's not, I guarantee it. Because think about 20 times 10, it's already 200, but your decimal places goof with it. So, check it. Now draw this on your paper. Area model rectangle. Now draw this on your paper. Just trust me, draw this. Trust me. Trust me. Well, growth opportunity. Aiden, growth opportunity. You have a hard time with these right now. You can't do them easily yet. You haven't mastered this yet. So, trust me. What is 2 times 1?
2.
Trust me, okay? What is 3 times 1? What is 2 times 4? What is 3 times 4? Now, we're going to go back and fix the decimals.
How do you know?
Just chill. I got you. I know exactly what you're going to ask. We got to go back and ask ourselves, hey, I have a lot of side chatter. I get it that you know how to multiply and you could grab a calculator and do it that way. But if I on a test say specifically set up an area model rectangle to do this multiplication, and then you come up to me and you're like, what's area model rectangle? I didn't ever do this because I just ignored you and I did stack multiplication. I'm going to tell you a tough noogies and I'm going to play you a sad, sad song in the tiniest violin. So, pay attention now. I got 10 minutes left. When we go back, Mr. Pearson, to fix the decimals, I look at the two numbers being multiplied and say how many decimal places were involved. None. Right? That's a whole number. No decimal places. 1, I give this 1 decimal place. None, 1. So I give this 1 decimal place. How many decimal places should be involved for my 12? 2. 1 from the 0.3, 1 from the 0.4. This is 0.5. 1, 2. Now, put it all together. 2, 8 and 3 together, that'll give us more than 1, right? That'll be 1.1. So this becomes 3 point, well then 1 and another 1, 2, and I could stack up my addition if I need to. This becomes 3.22.
That makes so much more sense.
Oh my.
And actually, here's like the grind of it. It's the same thing. This rectangle is the same thing as the stacked multiplication you used to do. Except instead of adding in those weird zeros and like pushing things over, like we just go and we check how many decimal places it should have based off where it is.
Oh, it makes so much more sense.
Questions on using the area model, because you're about to have to do it on your own. Yes.
That
Yes.
makes so much more sense. I didn't know like which ones you're supposed to multiply. So now I have to write it down. It makes so much more sense.
Now, give me your attention because I realized I didn't explain this well enough with Aiden saying what he just said. The reason we are multiplying what we're multiplying is we're physically treating this like the area of a room or any space. If I have this section and it is 2 by 1, 2 feet by 1 feet gives me an area of 2. If I have this section that is 0.3 times 1, the area is 0.3. If I have this section, 2 feet by 0.4 feet, the area is 0.8. What we're actually filling in here is the different sections of area.
Yeah, but how are you going to know you're 22? I get the 22.
So then we just add them all. So if I need to off to the side, I could write 2, and really I could just do 2.8, like I could automatically add those. Then plus a 0.3. I could do that. That gets me 3.1.
How did you get 2.8?
2 and 0.8. I just grabbed these together.
Oh, because
Because we have to put the whole thing together.
Okay.
I very much appreciate how willing you are to ask questions, Ava. Then I put the, and that's how we get the 3.22. I was saying that like as a big compliment, actually. Like, if I were to pick one person in this class that I think will do well based off asking questions, like other ones of you, like math abilities come and go, right? Depending on who you are. But Ava is the, like, maybe even in my 7 years of teaching, like you are just so willing to ask questions, and I love it. I absolutely love it. Yeah.
What if we don't need that?
That's perfect. But when Ava doesn't get something, she's like, hey, your job is to explain this to me. I love that. Seriously, thank you. Questions? We got to practice this on our own. Are we good?
Ew.
All right.
Either you're a ward or the most
We, by the way, this, like, bad. Try these. Now, these actually don't need to use the area model. The reason we use the area model is we had a whole number part and partial parts, right? 1 point something or 2 point something. Here, it's just 0.3 and 0.6. So there we can just multiply the 3 and the 6, but then you got to figure out how many decimal places does my answer have. Do it with your group. I will give you 2 to 3 to try this.
Yours has 2, and so it's too loud.
Those aren't the answers.
Oh. What? Okay. Alright. I thought you were not giving us any time to
No, those aren't the answers.
Those are similar to the answers.
Who compared me to
Me.
I'm sorry.
Wait a second.
I didn't negative
You don't have to look at the board. Who said, hey, look up here? Nobody. All right, we got to get in a little bit of random cards.
0.20.
Nora, what do I need to do to fix? What do I need to do to fix A? All I've done so far is I did 3 times 6 because I don't really like decimals. What do I need to do to fix it? Pass. Joey, what do I need to do to fix A?
So, because it's a decimal, so you gotta add a decimal point.
Where?
For the 18.
How do I know that?
Because there's two numbers behind the decimals in the problem, so like.
So Nora, did you hear what Joey just said? Alright, so Joey, say it again so Nora can hear you. But since you passed, I want to make sure that you get this. So say again what you just said.
Oh, you gotta place a decimal point in front of the 18 because there's two numbers behind the decimal in the problem. So, yeah.
When we look at the setup. Hey, do I need to switch your group? When we look at the setup, I have one decimal place here, one decimal place there. Two total have to be involved in my answer. Now, this gets weird though in B. Isaac, can you help me fix B?
Yeah. So, it's negative.
Oh, crap. There's a negative. Yeah, it's negative.
0.20.
How? No, wait. Negative 0.20. So there's one decimal place here and one decimal place there, but this doesn't really count, does it? Like, so wait, do I need to move this over and make it 0.02?
No.
I'm trying to, so
He's trying to trick you, Isaac.
I am trying to trick you. This is the issue that people come across. They will write out, oh, my answer's like 20, right? 4 times 5, 20. Negative here, because there's a negative. But then they say, well, really, I don't need this 0, so I can get rid of it. But now I only have one decimal place. That's not really true. Because when I did my math, I got 20. We're using 2 decimal places. Just one of them doesn't matter. Does that make sense? We can get rid of the 0, but right now we're using 2 decimal places, and this should be negative because there's one negative involved in the multiplication. Questions? Questions? Yes, but hang on. Nora, is this making a bit more sense now? Okay. So Aiden, help me out with C here.
Okay. First of all you have to do is put a 0 and a point and then you're done.
Yay.
First of all, what's the second of all then?
Okay, well there's no second of all. Okay, fine. There's just a 0 point and then there's 1 point and then you're done.
How do you know if it's positive or negative?
Because when you multiply a negative by a negative, it automatically makes it positive.
So this one is kind of like A, a little bit easier. 1 decimal place, 1 decimal place. I need 2 in my answer. Negative times negative makes positive.
Now you can't because I corrected you.
I told you guys those were not correct when I put them up there. It was on the way. So write down negative 2.4 times 5.3 on your paper. And so my caution is I would not blindly copy their rectangle because there's likely a mistake. So please ignore that this is here. Set up your own area rectangle to try to do this multiplication because one of them in their group says it's negative 4.8 or negative 8.48. Another one of the group members says it's negative 12.72. So we need to set up our rectangle multiplication and figure out who is actually right. So set this up, please. I'm going to swap my screens and go over.
Could we do one of these square thingies with
What, with like whole numbers like 54, 72 or something like that?
just 1 and 1.
No, well, I mean you can, but you don't need to.
I know, but like.
Not right now. No, you're not going to take classes. Hey, I have a lot of noise that I don't think is math related, and I'm trying to have somewhat of a math conversation, even though we're just kind of following like the whole why that wouldn't make sense.
Mr. Hudson.
Yes.
Is Jerry related to math?
Who?
Ron.
Yeah, well, one of them has the right answer and one of them doesn't. So.
Jerry.
No, we were talking about Jerry. Jerry's obviously.
Jerry's is Jerry.
Look, it's Ron.
So,
Good afternoon. Could I please have Mason Fields stop at the office? Mason Fields, please
Layla.
stop at the office. Also, a reminder that the Stillborn Middle School drama auditions for tonight.
have you figured out the
canceled.
mistake?
We still have auditions at Stillborn Middle
Which
School
might
on
be the mistake,
Thursday.
actually.
Thank you.
Why isn't the 0.4 negative?
Could not have asked a better question myself, Layla. When they set up their box, they said this is -2 plus 0.4. If we do this, we don't get -2.4. This should also be negative, which means this is -10. This is -0.6, but this should also be -2. The only positive, there is no positive up here, right? Negative times positive, negative times positive, negative times positive, negative times positive. This should also be negative. Sorry, all of these should be negative, so it should be the -12.72. All of this should be negative. Questions, comments, concerns?
You're an awesome math teacher.
Hey, give me your attention for just like 10 seconds. Please, please bring questions to class tomorrow if you're struggling with any of the homework from this week. Thursday, I'm going to be missing some of you guys for orchestra. Like, the rest of the week's going to go fast. So tomorrow, please bring homework questions if you got them. Thank you very much, guys. You guys go to advisory groups or like advisory rooms. If you need to figure out where you go and you're in my advisory, come see this.